Alright guys, quick video on volume of a cone using the shell method of integration, or you can also say kind of birthday hat. Make it a little simpler. Move that closer. Anyway, alright, we're going to start with a cross section of a cone and put another colored marker to make this a little more interesting. Purple is the only one I could find in our junk drawer, so here we got a cone like this. I want to find the volume, and we'll cut along this slice. Here's X, let's say Y, Z, and we'll slice here along the XZ plane. We use the shell method to integrate, find this. So let's take a look. Looking down the y-axis now. Okay, we've got this guy right here. Here's this cross section. Let's call this y naught. Y naught, right? H naught. And then we've got to find a point here along which we can integrate, which is kind of a general, I guess you'd say h comma y, right? Right here. This point along which we're going to kind of slide, integrate or whatever. Anyway, our thickness is our integral. It's going to be dy, or the independent variable, that little delta y, whatever symbology you want to use. And so that's going to be our variable, or if it were called the shell method. It's kind of like let's see, where should I draw this? I guess I'll draw it right here. This is our little shell along which we integrate. Drew it bigger just to illustrate. Here we've got our independent variable y, that's the radius. Thickness along which we integrate is dy. And so the formula for volume shell is going to be equal to, here, let me do this, make it a little easier to understand, hopefully. So the shell volume is equal to 2 pi times the radius times the height, and then your thickness. In this case it's dy. And we have to recall that the radius will just be y in this case, like I said. Here's our radius y. And the height has to be written in terms of y. So we're just going to look at this little element here and draw little two triangles that are similar. And what we have is y naught over h naught is equal to y over h. Here you can see that from this triangle, y naught over h naught, h over y, or y over h, excuse me, so that proportion right there. And our height right now is going to, or this height right here at this point, at any point, sorry, this height right here, at any point is going to be, you can see h naught minus that h, sorry, which is equal to h naught minus, so a little rearranging, y times, what is it going to be? H naught over y naught, right? This is our thickness right here. Shell height, in a way, sorry, not thickness, in terms of y, our independent variable. Cool, got it? There it is, h naught minus y times h naught over y naught, and we'll set up our integral now, integrate from 0 to y naught, here to here, 2 pi times the radius, it's going to be y, height, h naught minus y times h naught over y naught, and with respect to y. Distribute. Integrate. We've got y squared h naught over 2, y cubed over 3, h naught over y naught, and that's from 0 to y naught. Sorry, I forgot the 2 pi right there. All that times 2 pi. Okay. And zoom in a little bit on that guy. So you can see what I did. And then we just integrate for y. We'll take out this h naught, because you can tell h naught kind of is constant. It's multiplied by both. So 2 pi h naught. And then we'll plug in y naught squared over 2 minus, we've got our y naught cubed over 3 times y naught. One of those will cancel, and so we're left with 2 pi h naught y naught squared, 3 y naught squared minus y naught squared, 2 y naught squared over 6. Sorry, kind of simplified real quick there. You see we have y naught over 2 minus y naught, once these cancel, over 3. So we have 3 y naught squared minus 2 y naught squared over 6. And we're left with pi h naught y naught squared over 3, which some people can say y naught is the radius. You can see we integrated and then revolved around like this whole 360 degrees. And so alternately that can be written as, and this h naught can also be the height of the cone here, whatever this height is. So we can also write that as pi over 3 times r squared times height. And there we have it. Hope that was pretty self-explanatory, or well, easily explained. All right, thanks. Just let me know if you have any questions.